Alright, so for the first part of this video, we are going to learn how to express a quantity as a percentage of another quantity, or in short, expressing A as a percentage of B. But before we go into that, maybe let's look at context first. I'll say we have three good friends, Charlie, Chowdhury, and Bala, and they're doing a comparison of their weekly allowance. As you can see from the table, Charlie has $25, Chowdhury has $50, and Bala has $30. Well, quick math, you would be able to tell me that Chowdhury has twice as much as Charlie. Or another way to put it is Charlie has half as much as what Chowdhury has. So if Charlie has half as much as what Chowdhury has, then in terms of percentage, half would mean just a 50%, right? Okay, so Charlie's allowance is 50% of Chowdhury's. Then in the opposite direction, if if Chowdhury has twice as much as Charlie, two times as much as Charlie. In our previous lesson, we've learned that one whole is 100%. Two times meaning two wholes, then two wholes would mean 200% here. But if I have to compare between Bala and Chowdhury, it's not as straightforward anymore, isn't it? Bala's allowance is how many percent of Chowdhury? So is there a way that we can calculate? Now, before I were to introduce this form of calculation to you guys, maybe I'll convince you that it works for part A and part C as well. So I'm going to compare Charlie's allowance with Chowdhury for part A, using Chowdhury's allowance as the main base of comparison. So I will use Chowdhury's allowance in the denominator and Charlie's allowance in the numerator. Okay, convert this to percentage, and that gives me 50%, which is what we've agreed upon earlier on. Similarly, for part C, if I want to compare Chowdhury's allowance as a percentage of Charlie's, all right, so I'm now using Charlie's allowance as the main base here. If I'm using Charlie's allowance as the main base, then Charlie's allowance will be in the denominator and Chowdhury's allowance will be in the numerator. Multiply by 100%, and you realize we get 200% in this case. All right, so now let us go back to answer part B. Bala's allowance as a percentage of Chowdhury's. All right, percentage of Chowdhury's, meaning to say I'm using Chowdhury's allowance as a main base for comparison. So Chowdhury's allowance will go to the denominator. Bala's allowance will go to the numerator. Multiply by 100%, and you will get 60% in this case. Last but not least, Chowdhury's allowance as a percentage of Bala's. That means to say Bala's allowance will be in the denominator, Chowdhury's will be in the numerator. Multiply by 100%, key this quickly into your calculator, and you should get 166 and 2/3%. Okay, so from this quick simple exercise, you realize that if I want to express A as a percentage of B, A as a percentage of B, all right, then the quick math will be in the denominator will be B and A will be in the numerator, and I multiply by 100%. So that's how we express a quantity as a percentage of another quantity. So please take note of this part over here before we move on to the next part. Okay, so now let us try to put whatever we've just learned into practice. In this first example, we have 500 boys and 700 girls in a school. Now calculate the percentage of boys in the school. This is pretty much like a simple primary school question. So first of all, we're gonna find out the total number of students, and a quick math would be 1,200. So I'm gonna find the percentage of boys in the school. That means to say I need to express the percentage of boys, express number of boys as a percentage of number of students in the school times 100%. Key this into your calculator and you should get 41 and 2/3%. Now for part B, similarly, number of girls in the school. That means number of girls as a percentage of the total number of students in the school times 100%. And that should give us 58 and 1/3%. Now some of you may be asking, can I use 100% to deduct the percentage of boys? Of course you can do that and you should get the same answer as well. Now moving on to part C, number of boys as a percentage of the number of girls. Right, so please bear in mind over here, I should have a fraction, number of boys and number of girls. Number of girls should be in the denominator and the number of boys should be in the numerator. Multiply by 100% and that should give us 71 and 3/7%. So there you have it. Please jot this down before we move on to the next example. Okay, so here in the next example, we have two siblings, Ali and his sister. Ali is 24 years old, his sister is 30 years old. So part A, we're supposed to express Ali's age as a percentage of his sister's age. Okay, so as I've just learned, again, Ali's age as a percentage of his sister's age. That means sister's age should be in the denominator and Ali's age will be in the numerator. Multiply this by 100% and we should get as 80%. Right? Sorry, just allow me to do a quick check on the calculator. Yes, this is 80%. Now moving on to part B, his sister's age as a percentage of his age, of Ali's age. So it should be Ali's age in the denominator here in this case and his sister's age in the numerator. Multiply by 100% and that should give us 125%. All right. Moving on to this third example, we are asked to express 40 meters as a percentage of 2 kilometers. So again, applying what I just learned, in our denominator should be, yes, 2 kilometers, and the numerator should be 40 meters, and then multiply by 100%. Now, before you rush into keying things into your calculator, please bear in mind that before we perform the conversion, we got to make sure that both the numerator and the denominator are of the same units. So please bear in mind, numerator and denominator must be in the same units before conversion to percentage. All right. It's very clear to us that they are of a different unit. So what do? I just have to convert one of them from to be of the same unit as the other, which in this case, I would prefer to convert 2 kilometers to 2,000 meters. All right. Multiply by 100%. And you would realize that this is just 2%. Okay, so I hope everyone has taken note of this important pointer here, that the numerator and the denominator must be of the same units before conversion to percentage. Please bear that in mind and apply this knowledge when you try some of the practice questions later. Now in the next section of our video, we are going to learn about comparing quantities by percentage. Okay, so given the context here, now we have two gentlemen. Gentleman A, he earns $4,000 a month and he donates $1,000 to the charity. Whereas for gentleman B, he earns $600 a month and he donates $300 to the charity. Okay, of course, by just the mere comparison of the values, it would seem that gentleman A donates more than gentleman B, which is an obvious fact. But who, at the end of the day, is indeed more generous? And when we talk about generosity here, we are talking about the comparison of percentage of pay that goes to charity. Okay, so in other words, who is donating a higher percentage of what they earn to charity? Okay, so now let us consider gentleman A first. Gentleman A donates $1,000 to charity. So to find the percentage of the amount that goes to charity from his pay, it would be 1,000 over 4,000. Okay, expressing how much is donated to charity as a percentage of how much he earned, multiplied by 100%, and that should give us 25%. Whereas for gentleman B, you notice that uh, expressing how much he has donated as a percentage of how much he earned, multiplied by 100%, you realize that gentleman B actually donates 50% of how much he earns. So in this case, who is more generous? Well, we'll say gentleman B, for a very simple fact, because he donates a higher percentage of his pay, a higher percentage of his pay to charity as compared to gentleman A. Right now, the next part of this video will require everyone to refer to your 1B textbook. Now, this question is found on page 12, practice now 9. Now, at this juncture, if you need to pause the video to quickly go and grab your textbook, please go ahead. If not, I'm going to start going through this question now. Okay, so now we have this table over here that shows the amount of sugar found in each type of berry: blackberry, blueberry, raspberry, and strawberry. So our dear Cheryl here, her doctor advised her to reduce the sugar intake. So how should we go about advising Cheryl which of the 4 berries has the lowest sugar content? Now, to do that, I would say we need to find out the percentage of sugar um, in each fruit. All right, the percentage of sugar in its fruit should be the way to go. So let's start off with the blackberry first. And in this case, the amount of sugar in 9 grams of blackberry is 0.439. So expressing the sugar as a percentage of the mass of the fruit. Amount of sugar as the mass of the fruit multiplied by 100%. How much would that give us? Likewise, for blueberry, it's the same approach. 0.149 grams is the amount of sugar, and 1.5 grams is the mass of the fruit. Oops, sorry. Apologies for the technical fault there. Multiply by 100%, and what will this give us? Okay, at this point in time, if you'd like to try on your own, please carry on. Repeat the same workings for the other fruits as well. Okay, so we're going to do a calculation for the sugar content, for the percentage of sugar content in each fruit. So for the blackberry, if you punch the numbers into a calculator, you should get this value here in 5 significant figures, 4.8777%. For blueberry, the percentage of sugar we are looking at is 9.9333%. Whereas for the raspberry, in 5 significant figures, we are looking at 4.4210. And for strawberry, we are looking at 4.6571. Notice right here in this case, I'm using decimals instead of fractions, because if you do compare percentage by decimals, it would be clearer, it would be more obvious to us. Okay, sometimes for fractions, it is not that straightforward in terms of comparison for the quantity for the values itself. So right here, let's do a quick glance and you realize that raspberry has the lowest percentage in terms of sugar as compared to the other fruits. And therefore, we should advise Cheryl to take raspberry in this case because it has the lowest sugar content per gram. All right, the lowest sugar content per gram as compared to the other fruits. All right, so I hope you guys have a better understanding of how we can compare quantities by percentage. And yep, with this, I hope you'll be able to take away the knowledge that you learned from this video and apply them on the questions which you will be tasked to try. Thank you and have a great day ahead.